Hello, my name is Rick Barker, and I have a particular interest in paleoanthropology, a subject in which I was initially trained in Victoria University in Wellington in the mid-1960s under the instruction of Dr. Joan Metch at that time. I was also studying in education and later went into postgraduate work in behavioural sciences and related topics. So I've got quite a good background, or in fact very good background in anthropology, particularly physical anthropology and social anthropology. The interesting thing about anthropology is that it used to be very fashionable in the 60s, 70s and 80s with people such as the Leakeys, who published many books, particularly with their finds in Africa. And as things happen in the 90s, other things became fashionable. And luckily for me and people like me, human interest in humans and their history and paleoanthropology and related subjects has become fashionable again, which is will happen if you just wait long enough. One thing I have been researching over the last year is the latest work to do with the development of chimpanzees, that is pan-troglodytes, that is common chimpanzee, and hominids, which are our extinct relatives. The only people left today in the human line are us, which is Homo sapien. And the word that is used a great deal in anthropology is anatomically modern humans, which describes us. All other humans, or all other hominins, are described as anatomically archaic, that they do not have the same skeletal structure as us, but genetically they are very similar. Of particular interest at this present time is speculation on what the last common ancestor of the common chimpanzee and us may be. Two works of particular importance. 2005 Nature published the comparison between the chimpanzee genome and the human genome, and that has had a lot of follow-on effects. The other one is the work of Lovejoy, who did a lot of studies on what is called Ardipithecus ramidus, which was found in Ethiopia, female skeleton, about 4.4 million years old. And that has given us some clues regarding what the common ape ancestor of us and the chimpanzees might be like. This was a remarkable find that was just found by accident and in very poor condition. It took years to actually dig it out and actually manage to piece it all together, more than 100 bones, including the hands and the feet, which is very important. What Lovejoy's work indicates is that the common ancestor, which was probably about 6 million years ago or so, was probably a rather basic sort of ape. One that could walk upright if needs be, certainly arboreal, but probably not able to get right up into the top of the trees like the common chimpanzee does today. Mainly because of speculated differences in the skeletal structure. The skeleton of the Ardipithecus demonstrated several things. One was that it had an opposable toe, which means that that creature, 4.4 million years old, lived a lot in the trees and probably lived in a woodland environment rather than equatorial rainforest, which most chimpanzees live in today. This creature also, by study of its feet, could also walk upright on the ground, and it also had a stiffened large toe, which is something we have. So it seems that we may have come down either through the line of the Ardipithecus or some related species. There have been many studies done in recent times concerning the locomotion of common chimpanzees and us. There are a number of differences which seem to have occurred since we split about 6 million years ago. Of particular interest to the common chimpanzee is the bent knee and bent hip gait. If you look at videos of common chimpanzee walking, you'll notice that they seem to stumble about quite a bit as they're walking along. This is because their spine is not the same as ours. Our spine is S-shaped, and in our lumbar region, which is near the base of the spine, we are quite flexible. The chimpanzee spine is not flexible in this area at all, but they are flexible down in the knees and the hips. And this helps them to get their centre of gravity and balance when they're walking on the ground. One difficulty is that they use something like 70% more energy to do this than we do. So they are very inefficient when it comes to walking any long distance. However, they more than make up for it when they get up in the trees. One thing that the common chimpanzees can do that we cannot do is called vertical climbing. If you see a group of chimpanzees under a tree and disturb them, they will shoot straight up into the tree very, very quickly, almost instantaneously. This is a particular feature that they have developed called vertical climbing. They also are suspensory, meaning they can hang from their very, very long and very, very strong arms. Their arms are about 6 times stronger than ours. This means that they are extremely mobile in trees. They are able to walk with an upright gait over tree branches. This is particularly when they want to get fruit. Most fruit is found at the edge or the top of trees, which chimpanzees have adapted to reaching very efficiently, probably much more so than the original common ancestor. What they do is that they use plantigrade, which means that they can walk along the branch and they hold on with their hands to the upper branches to keep their balance. They can also lean out and grab the fruit, such things as figs and other types of fruit, which they rely on very greatly in the fruiting season. In the off-season, they can eat what are called C3 carbon plants, which are broadleaf plants. They can process those plants where humans cannot anymore. We've lost the use of our caecum or appendix, which means that they can exist on a broader diet up in the trees than you and I could possibly do. Plus they supplement their food with such things as termites, small animals, chimpanzees. Both species of chimpanzees, bonobos and common chimpanzees, can hunt in a very planned, almost eerily human manner. And they catch other monkeys, and common chimpanzees also can catch antelopes and wild pigs. Indeed, there was a picture in the National Geographic a little while ago where 4 chimpanzees had caught a pig, and they all grabbed a limb each and tore the thing in half. They were that strong. So they're very much stronger than us. It'll do for diet, I think.
All right.
One of the controversies in the 20th century was concerning bipedalism and whether humans or homonyms, our extinct ancestors, first acquired bipedalism, or did they acquire a large brain first? And this went on and on and on. The answer is very clear these days that bipedalism is the distinguishing feature by far. The brain actually didn't greatly enlarge until about 2 million years ago, around the time of Homo erectus. So bipedalism is the main distinguishing feature. To go back to the Ardipithecus again, 4.4 million years ago, that creature could walk on the ground, apparently reasonably efficiently, as well as having an opposable toe. It also had much longer arms than us, much longer fingers, and the brain was about the same as a chimpanzee. Mustn't underestimate the chimpanzee. A chimpanzee has a brain that is about 3 times larger than it should be. So chimpanzees actually are large-brained creatures for their body size. Humans, on the other hand, have a brain very, very much bigger than the chimpanzee, 3 times bigger again. Huge, absolutely huge. But the initial change was the bipedalism and not the brain, which we shall talk about later. If we move a bit more forward from 4.4 million years ago to about 2.2 million years ago, there's another creature called Lucy who is well known. Lucy is a creature that was bipedal. No arguments about this. It was a form of Australopithecine africanus. Both Lucy and Ardi were females, just for the record, so there's no sex discrimination here. There's no doubt that Lucy was bipedal, fully bipedal. And as I've already mentioned, both Lucy and Ardi are classified as homonyms and not as apes. So we must make that distinction, that humans are not apes as such, but we're very ape-like, and there's no doubt that we have come down through that line, no doubt at all. One of the things also that caused controversy in the 20th century was the assumption that our ancestors started up in the equatorial trees and then adapted rather quickly to savanna land. And this has been shown not to be the case nowadays, that indeed, particularly progress in climatology has shown that there was a gradual transition through the Miocene into more modern times. The earth is drying out, particularly in Africa and Asia, where the tropical rainforests have shrunk, replaced by woodland forests, which Ardi probably lived in, and then even later the spread of savanna lands and grasslands, which has led to carbon-4, C4 type plants, which are very important in our evolution. The ability to survive on savanna land means you must be able to walk a long way, unlike the chimpanzees, which live in a very restricted local area. From about 2 million years ago, from about the time of Homo erectus, people started moving or walking out of Africa, probably following animals out. They didn't deliberately go, they wouldn't have known the difference between Africa and Eurasia. Probably following the food supply, started moving into Eurasia and have been doing that for about 2 million years. The fossil record's a bit confusing as to how many different groups there are, but there are more and more groups turning up, so there were probably lots of groups, local groups, as they move further into Asia, China, Indonesia, Middle East, Southern Europe, Northern Europe and Central Asia. They seem to have turned up all over the place. They can only do that by very efficient walking. They can only do that by very efficient food gathering, which is more than just gathering things like figs from trees and living on broadleaf plants. These people must have acquired the ability to find food on the ground, digging up tubers and so forth. Less than 2 million years ago, they have obviously discovered how to use such things as fire, more advanced technology, better hunting, and the ability to adapt to climates which were no longer warm. Africa is generally pretty warm. We know that Homo erectus, for instance, lived in northern China. It's freezing cold. We also know that they also built hearths, so they had some control over fire. One thing that a lot of research has been done into more recently is, particularly in the area of the behavioural sciences, is the development of the human brain. Human brain takes an enormous amount of energy. More than 20% of the energy that we consume goes into our brain. So it takes an enormous amount of energy, more than any other living thing ever. Our brain is really important. The latest research in fetal development has shown that the placenta will actually, if the mother is malnourished, the placenta will actually break down some of its own tissue and feed the brain of the developing fetus. So it's obviously very important at a very early stage. You shouldn't underestimate the brain capacity of chimpanzees, however. They have a very large brain. As I've already mentioned, about 3 times bigger than it would normally be on other mammals. They have also demonstrated in the 1960s and 70s in particular that some chimpanzees, a small number, can be taught the American single-handed sign language, and the chimpanzees have done rather well on that. So there's no doubt that they can communicate using that particular medium. Also very simple types of computers, just with very, very basic symbols on, usually about half a dozen. They've been able to do that too, so that they can be taught things. This may be involved with what are called mirror neurons, where you can copy the behaviour of another being, common to monkeys, apes and humans. You see someone doing something and you, by watching them closely, may be able to repeat that action yourself. One difficulty with the sign language argument is that it may resemble something like training circus animals, because they were given lots of rewards and also removed from other chimpanzees for the most part. Big arguments with some people over this, who claim that human language is innate, in other words it's inherited, and there is certainly some evidence for that. People such as Noam Chomsky got into quite big arguments about this sort of thing, but he got rather distracted on arguments of universal grammar, which people don't really follow very much now. But there's little doubt that humans have very complex language, which must be to do a lot with our brain and the way our brain operates. Also, we have a high degree of recursion in our language. That means we are able to repeat things in almost an indefinite number of ways, over and over again. If you don't understand what I'm talking about, I can rephrase it and rephrase it and rephrase it. This type of recursion is not found in any other animal, so these days, in the last few years, there has been quite a lot of work done on complex recursive human speech. Recursion is something that humans specialise in. Some people would say we are not the only living creatures to use recursion. Songbirds, for instance, are known to repeat and improvise. Humans, however, are quite unique in the way that we can revise what we say over and over and over again, almost in an infinite manner, that we can keep on retelling our present, our past and our future. And there's not much real evidence that other animals have developed this facility. Right, another matter which is one of some controversy is complex human speech relating to what's called recursion. Recursion, when I use that word, I mean that the ability that modern humans have to repeat themselves or a story over and over and over again, not only in present time but also in past time and in future time, and in scientific jargon, in poetic jargon, in singing and dancing and painting. It's quite enormous, and there are really no other members of the animal kingdom that can do things like humans do in that regard. Certainly there is evidence concerning animals such as songbirds, thrushes for instance, one popular candidate, where they do start with a certain basic number of tunes, shall we say, not very many, and then they can get quite recursive in the way that they can make up their own after a while. So there's no doubt that animals can make up their own things in a recursive way, but none of them can read or write, tell stories, or have gods that I know of. Another thing to do with chimpanzees and also all primates is the use of body language, that we have a great innate knowledge of body language, which all primates seem to have. You can tell when a primate, even if it's a monkey or something, or a lemur, you can tell when they're angry, you can tell when they're happy, you can tell when they're nasty, you can tell when they're bad-tempered. Another person who had things to say about that in 1871 was Charles Darwin, in his book The Descent of Man, where he lists in chapter 2 a whole list of attributes that primates have, including fear, jealousy, trickery and so forth, all of which have turned out to be correct. There used to be an idea that things such as reciprocity or altruism, that is helping other people, you do for me, I'll do for you, was a purely human phenomenon. That is not true. Altruism and reciprocity are found throughout primates. All primates are social to a greater or lesser degree. Also found very, very widely in birds, such as our kookaburra, for instance. Very slow breeders. The whole of the kookaburra clan that it's born with assists with the bringing up of the kookaburra. So there's nothing particularly unique about us forming alliances or forming even political alliances. It has been well observed in chimpanzees that they do this sort of thing very, very well. And therefore we can suppose this behaviour is not uniquely human, that it's something that we have inherited through a long history of primate cooperation, and also primates living in particular social groups. But humans, of course, have advanced this into such things as formal warfare and alliances and states and so forth, which other animals can't do. But certainly many animals are very protective of their immediate environment, which they regard as their own, and they're quite prepared to fight and die for it. So these things can be considered part and parcel of being part of the animal kingdom. One very, very important event, probably not recently, maybe about 6 million years ago, was a chromosomal mutation which split us off from the great apes. As ape-like as we might be at times, we are not classified as a great ape. As far as chromosomes go, apes have 48 chromosomes. We have 46. And this came about by a chromosomal mutation, not recently, probably about 6 million years ago or so. This was caused by the fusion of the ends of the chromosomes called telomeres, which means that the ancestor, or ancestors, depending how you work it out, of humans have 46 chromosomes and the rest of the apes have 48. This means that at that time, if they interbred, which they must have done, they wouldn't have been able to tell the difference. If they had interbred, the offspring would almost certainly be sterile. Much the same as if you breed a horse and a donkey. The same thing happens. Occasionally you might get a fertile one, what's called polyploidy, which means some extra copies have turned up, but it's most unusual. Because of this, our line has split permanently. There were actually proposals in the Soviet Union in the 1930s along the lines of trying to breed perhaps a cross between a human and a chimpanzee, but I understand that a guy called Stalin found out about it and decided that was not good publicity and put a stop to it. So it was actually seriously considered at one time. In 2005, Nature magazine published the results of the comparison between the human and chimpanzee genomes. Much of the genomes are very, very similar. Indeed, if you count insertions and deletions, which you have to count in, the difference is about 4%. That's the figure used by the National Institutes of Health. Don't believe those 1% claims, that's just on nucleotide counts. You've got to include the insertions and deletions to give you a full count. So it's about 96%. And that's from the National Institutes of Health, and you can't argue with them. The other thing that is shown up in humans, a lot of selective sweeps in quite recent times, like the last 250,000 years ago. These selective sweeps apply to us, anatomically modern humans. Over above 250,000 years, selective sweeps, which are genetic sweeps that can go through a population, tend to fade out of the genome, so they get lost. So you can't really track them down before that time, but there have been quite a number that have affected us, including the development of the brain, particularly the forebrain, in recent times, which is known as human, this is known as human accelerated region 1. Another difference in the genome between chimpanzees and us is AIDS. They have a disease called SIV to which they are immune. It is thought, looking at their genome, that there was perhaps once an SIV, AIDS type epidemic in the chimpanzees, and they acquired a resistance to it. In the 20th century, that disease has jumped species into humans, and we do not have that immunity, as we all know. Big problems. So they have been able to find effective treatments to lessen the effects of this disease of AIDS, but there is no cure. At the moment, they keep on putting a lot of money into it, but treatment hasn't improved. That's all you can say for the people that have it. I'm sure somebody's looking at me in there. That's me.
They will be.
One line of research at the moment is looking at the history of SIV in chimpanzees and seeing if they can find what resistance or what part of their genome is resistant, and perhaps they can transfer that into humans. So we'll just hope that that turns out to be a success. Another matter of interest in the social and behavioural sciences is the way that chimpanzees have developed their kinship relationships, that as with most, if not all, social animals, they have a system of hierarchies where there is a, to use a common phrase, a top dog or a pecking order, shall we say, and who you are in the pecking order depends how much authority you have. And chimpanzees have structures which are not altogether dissimilar to ours in many, many ways. Female chimpanzees generally leave the group when they become sexually mature and have to enter another group, which means that they have to start at the bottom and work their way up. And it may take a long time because they're strangers to the group. The males tend to stay in the groups where they are. But this doesn't mean that the females don't have some control over things. There was a very interesting program on television a little while ago where a leader in a troop of common chimpanzees was bullying the rest of the troop around, and a group of 7 females actually ganged up on the male and deposed him and put another one in. So it doesn't all just happen on violence and physical strength, that these females actually permanently replaced him with another one, the next one down on the group. So it reminds us of some of the political machinations recently in Australia, perhaps, of this sort of thing happening. The other thing they do, rather like humans, is that they form alliances and friendships and enemies. It seems that chimpanzees also don't like some of their fellow chimpanzees the same as we do. They are also prone to doing favours, giving food to particular ones that they like and not to others. This is, of course, very common behaviour with humans as well. Also, chimpanzees are very, very protective of the range that they occupy. One of their greatest enemies are other groups of chimpanzees, that they're constantly on the outlook for any groups of chimpanzees that try and take their particular lie of the land over, and they will fight back if that happens in ways which look rather like us defending our land too. On the other hand, it's quite common with creatures such as wolves, for instance, and dolphins also do the same thing. So the idea of defending one's home territory is very widespread in the animal kingdom. Another matter of interest with chimpanzees is that they are aware of things such as death and dying. Some recent publicity on this where female chimpanzees, if the young one dies, will sometimes carry them around for several days and are obviously quite distraught. They don't exactly hold funeral rites or anything, but they are obviously very distressed, and often the rest of the group is quite distressed if one of them dies like that or becomes very, very sick. They become quite attentive. Also very commonly found in elephants. So this is another behaviour which is found in social animals. Elephants, in this case elephants, chimpanzees, and us. Two things that common chimpanzees and humans have in common. The males generally have control over the resources, and the females. Even though in our modern society females get a lot more opportunities than they used to, the general pattern has been that males, when push comes to shove, shall we say, with common chimpanzees and humans, it's the males who control the food resources, and often the access to females. Although in the human situation that has rather changed as humans have become more and more modernised, we've become more monogamous.
This way a bit more.
Well, chimpanzees went up into the trees, right to the top.
Oh, okay.
That's why they're so beautifully adapted for what is a very large. Some of them weigh up to nearly 45 k's. It's hell of big for an animal to be so acrobatic up there. Amazing. That anything that heavy can be. I mean, the gorilla doesn't do too well, but they're pretty big. So, right, is that on? Another controversy from the 20th century was concerning knuckle walking, as to whether we had started as some sort of chimpanzee-like creature, gone through a stage of knuckle walking, and then achieved full bipedalism. Now, this idea has been refuted these days. The chimpanzee is actually, like the human, quite a modern creature. It is no proxy for the last common ancestor at all. The assumption was in the 19th to 20th centuries that chimpanzees were some sort of primitive beast which we left behind a long, long time ago. The present day evidence indicates very, very strongly that the chimpanzee and us, including the genetic evidence, have both changed a great deal in that time. We must remember that during the Miocene period and later into the Pleistocene, that the world's climate has changed very greatly and has been slowly drying out, and that the ecological nature of the environment has changed a great deal. The chimpanzees have adapted beautifully to getting up to the top of those mostly equatorial trees, or in Western Africa in the wet savanna woodland area where they live very well. The other thing that happened was that because of the change in climate, trees tended to grow more in clumps, which means that the chimpanzee is going to have to be able to walk from one group of trees, if necessary, to another group. They're no longer one huge united rainforest. And during this time, the chimpanzee and the gorilla developed knuckle walking, which is something completely unique to the gorilla and the chimpanzee, and there is no evidence whatever in the fossil record that humans or hominins or their ancestors ever went through that phase. So that idea is pretty much gone these days. There's just no fossil evidence that this happened. One important thing with Ardi 4.4 million years ago was that particular creature had both features. Still had opposable toe, but a stiffened toe and a gait which was obviously much more efficient at walking on the ground, as well as getting up into woodlands, not into equatorial forest land. Chimpanzees are always trapped by their environment. They've adapted to living in an arboreal landscape, fitness landscape, plus being able to walk on the ground and walk around if needs be, and if needs be collect food from the ground too. They can do that. They have got that far, but unlike humans, they never learnt to walk long distances. Experiments have been done on treadmills with chimpanzees being bribed with food to walk on treadmills, both with upright walking and with knuckle walking, and it has been found that they're quite good at both. That their upright walking is actually quite good for short distances. The problem is they use about 70% more energy than humans. So they are very inefficient over any long distance, whereas the human upright gait, we can go for a very, very long time jogging or striding over very, very long distances. With the change, particularly in climatology, where there was a reduction in equatorial forests. At one time, for instance, during the Miocene, the equatorial forests between Eurasia and Africa were linked. That's how the apes got across from Eurasia into Africa. As time has gone on and on and on, it's got drier and drier and drier. The chimpanzees have not adapted to this dryness, except for knuckle walking, where they can actually be rather more mobile than they were before. But the human or hominin line has adapted enormously over time, where it's gone from the equatorial to the more open woodland, which requires walking, to adaptations to savanna land. And the savanna lands, of course, are quite extensive, right through North Africa, East Africa, and very large proportions of Central Asia, right through Eurasia, except in the tropical bits, huge grasslands. And we have adapted to those and utilising those grasslands over time, which has required, well, has resulted in an increase in the size of the brain and the complexity of the brain. If you're going to survive out on savanna land or grassland, you're very exposed. You can't just go, there are no trees often to get up. You are in great danger. You will have to improve your social skills, your reciprocity, your mutual support will have to improve. The other thing is this, that the hunters, the males, have to travel long distances often to get food. That means the females are being left behind. Human babies, particularly over the last 2 million years or so, when we've become larger brained and much more modern than the early Australopithecines, humans have required that they get more structured in their social arrangements and have tended much more towards monogamous relationships where the male can go away and come back to help raise the children. It's a cooperative effort. Mother can't raise the children or a child by herself. So that the idea that humans have or are still tend to invest more in their immediate family than in other families. This just seems to be a natural way of doing things. And humans themselves have, over the last 10,000 years in particular, since ice ages stopped, human cultural growth has been simply enormous. There's nothing like it in the history of the Earth. That from about 12,000 years ago, when the ice ages finally stopped, the Earth's climate has improved. Humans, being primates, prefer warmer climates. It has also given much more opportunities for crops to grow, and of course it's not long before humans, say less than 12,000 years ago, started not only cultivating crops or cultivating crops as a cultural practice, but also domesticating animals. And since that time, recorded history has much improved, so we know a lot more about what's happened, particularly since the invention of writing. Probably, perhaps the Sumerians, those sort of people, the Chinese, later the Egyptians, not much later. So that we actually have a written history also and a cultural history, which is very important in paleoanthropology as far as working things out. These days, people do not work in their own discipline very often because it's become very interdisciplinary. You have to be able to read other people's papers. Also these days, if you want funding, there's not much room for lone rangers, that you have to work with other people and have to work in teams. That's the way you'll get the money. Also, working with other people is they're going to pick up on your mistakes. And you can't, the nature of knowledge now is such that you can't possibly know everything. So it's better to specialise in certain areas and be good at them and let other people get on with theirs, rather than try and turn yourself into some sort of perpetual student. It doesn't work anymore. Unless you're writing for popular science magazines or something, it might. But people are, I think, specialising more in their own fields. And I would say since 2005, the quality of scientific research in anthropology, social sciences, genetics is actually going up. We went through our stage of popular science in the 80s and 90s, which was actually quite a good thing. It got people interested in things. And at least popular science does keep people interested. Some people are rather critical of it. And they're not always wrong anyway. Sometimes the ideas they come up with prove to be right. So you can't always rely just on mainstream science for everything. Many people who work in more formal areas of science quite against popular science, but well, how else is science going to get in the newspapers and on TV? The other thing that when I'm talking to people who get rather annoyed about this is I say to them, you must remember that the general audience is watching this sort of thing because they're interested in it, and they're not there going, that's wrong, that's a lie, that's not correct. I said that's not how they're reading the message. And I also say to them, all you have to do, if someone comes along with an argument which is obviously outdated, but they obviously like it, all I say is, well, that was a popular idea, but there's some new evidence which says something a bit different. And what do they say? They say, what's the new evidence? And you shouldn't fall into the trap of getting into what are called graveyard science arguments about arguing about who said what in the 1990s. It doesn't matter anymore. There's a whole new generation of people coming through, very technologically savvy, and they're thinking about things differently. And you have to make way for the new generation. You just can't have the old ones controlling things all the time. Any more of this and I'll be turning into a priest. But when you look at this, it all seems a bit obvious, but 10 years ago it wasn't. It's quite interesting.
What's it?
You know, I look at it and think, well, it must be pretty obvious that we didn't have knuckle walking. I mean, you know, but when you go back, well, my initial training was in the mid-60s. It was quite, I mean, the humans were divided up into races at that time. I mean, it's quite different now. I mean, some people still try and keep that going, but it's interesting how I think it's improving. Some people are getting quite despondent about the whole thing, say 10 years ago, but it's changed since about 2005, and one of the big influences is the internet. Well, I can look up stuff from all over the world, which in a backwater like Australia, and it isn't in some ways a backwater when it comes to trying to get my hands on the latest scientific stuff. I've got to go and order it. I've got to go and order 2 more tomorrow, actually, because there's not a big market for it here. Whereas you get in the US and in the UK, concentrations of people working in the same field, all in the same area. A bit hard here because we're spread out so far and we're much smaller. One of the big controversies has been in the 20th century whether or not... Oh shit!
That's alright.
Oh, yes.
There'll be an outtake.
Yes.
Bloopers reel. It's alright though. There we go.
Yeah, that'll make me look good, yes. So our brain is absolutely crucial to us. Indeed, the very latest research I've just been reading about to do with the placenta, that should the mother be malnourished, the placenta will actually use part of its energy reserves to develop the fetal brain of the developing youngster. So our brain is absolutely crucial to us. But you shouldn't underestimate the intelligence of chimpanzees. We know from work done particularly in the 1960s and 70s, that some chimpanzees, and only a few, have managed to acquire the American single-handed sign language to quite an efficient sort of degree, to the degree that they can communicate usually with the people that have taught them.